as far as security goes when they move to the cloud, because they've heavily invested in time and resources to properly secure their on-premises environment. Oh, tea time, Massimo. Oh, tea time. Great. Yes, so they heavily invested, and now they are afraid that by moving to the cloud, they'll lose all that security that they heavily invested into. So when I talk to networking people, as I mentioned earlier, what I like to tell them is, listen, be confident. Everything you had on premises, we can easily mimic on AWS Cloud. So tell me what your configurations are, and we can mimic something similar on AWS Cloud with the same, at least same security controls. But most likely we can have even more. So therefore, your environment will end up being more secure than it was when it was on premises, as you just lift and shift it and move it to the cloud. A good example of that, AWS Shield, which comes free of charge to all clients, that prevents DDoS attacks, or if you wish, distributed denial of service attacks. So just by moving to the cloud, you have that built in. So therefore, it's going to be maybe a security control more than you had on premises, maybe. So the way it works with components around what we call the virtual private cloud, or, of course, hold on a second. My pen, where's my pen? Yes, so around the virtual private cloud, or VPC. So in the VPC, which is an isolated environment on AWS Cloud where you deploy your resources, and you configure any connectivity by using well-known components for networking peoples. We can use subnets, we're going to use gateways, things like that. So let me explain a bit what it looks like, what it could look like in the case of a VPC. So let's use that digital board. So when you publish resources on AWS Cloud, actually when you sign up for an AWS account, it creates a default VPC for you. A VPC is an isolated environment on AWS Cloud in which you can deploy your resources. And by default, in a VPC, there is no connections that can come in from the outside, nor are there any connections from the inside that can get out by default. Of course, you can configure that, you can change that, but by default, that's how it behaves. It's blocked, all right? And you can create additional VPCs. So several customers are isolating applications into a VPC. So they will have one application into a VPC, another application into another VPC, and so on and so forth. I've seen an organization having only one VPC, but using subnets within the VPC to segregate applications and resources. I've seen that as well. You could have different environments for the same application in different VPCs. Take environments such as SAP, where you've got a dev environment, where you've got a QA environment, and where you've got a production environment. So all three could be in different separate VPCs, resulting in 3 different VPCs for the SAP environment. All right, so there are different strategies around the VPCs. But then your VPC, when you define a VPC, you got to assign a CIDR IP address range. So basically a range of IP address that will be used by your VPC. And I am not a networking person, so bear with me. Those numbers that I'm going to put there might not even make sense, but bear with me. So you will assign an address range for the entire VPC. So it could be 10.0.0.0/16. But then within your VPC, you can segregate resources furthermore by using subnets. And networking people are familiar with subnets. They all understand what it is. So you can create a subnet, let's say for your web servers, and then create another subnet, maybe for your backend servers. So here, that could be subnet A, and here that could be subnet B. And to each subnet, you will also assign an IP address range, but an IP address range that must come from the master IP address range here. So for example, it could be 10.0.1.0/24. Here it could be 10.0.2.0/24. And then you'll deploy your resources, which could be virtual machines. In this case, could be EC2 instances. All right. But yet again, by default, nothing can get out of the VPC and nothing can come in. But those are web servers. What if I need to receive connections from the internet? I need to receive connections from my customers. Well, for that, I will need to introduce an internet gateway. So the internet gateway will allow you to define route table entries. So you can have a route table entry stating that maybe connections from any IP address as a source, but on a specific port gets redirected to that subnet, subnet A. So right there, it's your first level of security, because without that route, you cannot access the network. So for example, people from the outside cannot access this subnet here because I have no route defined in the route table. So therefore, it can only go there to that subnet. So because that subnet now receives connections from the internet, it now becomes a public subnet. As opposed to this one here, which does not receive any connections from the outside, the internet, so therefore it stays a private subnet. All right. But I also need my administrators to be able not only to connect to the public subnet, but the private subnet as well, to be able to manage those machines. Can I do that? Absolutely. You could use what we call a virtual private gateway. The virtual private gateway will allow you to create a VPN connection. So it's going to be secured. It's going to be using IPsec. So that's going to be a secured VPN. And again, using routes, you'll define a route table entry that will allow you to reach each subnet. So now your internal people from the corporate data center now have access to those two subnets. And you can even define the source. So it could be specific IP addresses for just your sysadmins that really require access to those systems. And you can add on top of that IAM and all other type of authentication mechanism on top of that. But that's just to give you an idea of another layer of security here through those route tables. Now, those systems happen to be Microsoft web servers, and those are Microsoft SQL database servers. So I would like to be able to go and get Microsoft updates from the internet. So in that case, what can I do? Well, I can introduce a NAT gateway. And again, through route tables, I'm going to define that those two networks can access the outside. Right? So as you can see, without those components, without those route table entries, there's no communication. So right there, it's a first level of security. You can control exactly which traffic can go where. But on top of that, you can add additional security layers, such as one that is here at the subnet level, which is a virtual firewall. So it's a virtual firewall at the subnet level that controls the traffic that can come in or get out of the entire subnet. Those are what we call network access control lists, or NACLs. So through NACL's inbound and outbound rules, you'll define what traffic can actually get into that subnet or get out of that subnet. So see right there, another layer of security. And to add on top of that, there's another virtual firewall, but this time is at it is at the instance level, the EC2 instance level. And actually, I could have more than one into the same virtual firewall. And those are what we call security groups. So we've got security groups, another virtual firewall, for which you'll also define inbound and outbound rules. Without those, nothing can come in or get out. So as you can see, and we're just talking at the network level, but there's already several layers of security. That's the AWS approach to security. It's a layered approach. There are several layers available. It's up to you to use whichever ones you want. You could use just one of them, all of them. It really is up to you. All right? But it's your responsibility as a customer or your customers. All right, so that's it for VPCs. As you can see, again, really secure. And there's additional services as well. There are some that we will cover later, some that are not covered in that course. But just note that there's a lot more layers of security. For example, DDoS protection. We've got web application firewall, which is another virtual firewall, but this time at the web application level. Yes, exactly, Mohammed. Absolutely. Those here, I'm just talking virtual firewall. I'm not talking about any sorts of authentication here, because on top of that, you are correct. You could either use identity and access management, or IAM, to decide who can access those virtual machines, so which users are allowed. But also, you could use Active Directory integration and use single sign-on. So you could use your Active Directory account to reach out to those machines. There's other security layers as well on top of that. You are correct. All right. And as I mentioned, there are several approaches to VPCs. When you, as far as the number of VPCs you will create and what you will put in those VPCs. So there are several approaches. And as I mentioned, one very popular one is to have one VPC for each environment of an application. So again, let's get back to my SAP example. So when you deal with SAP environments, you've got a dev environment, then you've got your quality assurance environment, or test environment, if you wish, and then you've got your production environment. So what you want to be able to do is you would like your developers to develop their application here. But then once they're done, you would like these guys to be able to push those changes to the test environment so that people can exhaustively test it. Well, in that case, what you could do, you could configure what we call VPC pairing and create a pair between those two VPCs, which means people will now be able from here to access there and there to access here, so that they can actually transfer the changes and then test those changes. And once they are happy with those changes and they've exhaustively tested those, now they would like to push those into production. Well, you can create another VPC peering pair between those two networks. So they'll be able to push those changes there. However, not because you've created a pair here and a pair there, that it automatically pairs those two. No, because you don't want people to push changes from dev directly to production. You don't want that. So simply don't create a pair here. And that's it. All right. So that's how it works when you create VPC peering pairs. All right. So now that we know about VPCs and we've got resources deployed in there, how do we connect our data center, our corporate data center, with our VPC or VPCs? Well, quite simple. First, there's the VPN that I've explained. So I could put a virtual private gateway. So create a VPN between my data center, my corporate data center, and my VPC. That's one way to do it. Again, it's going to be secure through IPsec. But as you can see, it goes over the internet. And the problem with that is that the internet is a shared resource, which means the bandwidth is not guaranteed. What if you've got a significant amount of data that transits regularly, maybe on a daily basis, between your corporate data center and your AWS VPC? Well, something you could do is use AWS Direct Connect. What is AWS Direct Connect? It's a pretty cool service where AWS basically made a deal with a bunch of partners of telco providers. And what they did, those providers, those partners allowed AWS to directly connect the AWS backbone to the telco provider backbone. And then your customer, or you as a customer, can rent a dedicated connection from your data center to that telco provider. So therefore, an MPLS link. All right. So having that link directly connecting your data center to your telco provider, and then the telco provider being directly connected to the AWS backbone, that gives you a direct connection from your data center to your VPC without ever going over the internet. And there are several bandwidth availability that you can subscribe to. So for example, I think there's 1 gig, 4 gigs, and 10 gigs. Could be more, I don't know. You can look into that because those change constantly. So this will give you a direct connection for which the bandwidth is guaranteed, because now you're not sharing it with anybody else. It's yours. All right. I would believe so. I would believe so. All right. Now, let's talk about CloudFront. What is CloudFront exactly? Well, to explain that, I told you that typically in this course, I do not do any whiteboard sessions. I reserve that for the Cloud Practitioner Essentials course. Well, I lied to you. There's one whiteboard session that I would like to do with you and go over. Let me end this for a second. And let me bring you my Miro whiteboard. All right. So when I explain the global infrastructure, the AWS global infrastructure, there's one more component that I didn't explain yet. So remember, there are regions, right? We've got 26 regions, which are made of availability zones. So we've got a total of over 84 availability zones across our 26 regions. And those availability zones are made of several data centers, discrete data centers. Awesome. We understand all that. However, let me explain to you a scenario, because there's one more component that I didn't explain, which are edge locations. Oh, sorry about that. Edge locations. What are edge locations? Let me explain. I've got a user here, little Carl, and little Carl happens to be in Australia today. So I am in Australia, and I would like to watch a Netflix movie or an Amazon Prime Video that happens to be hosted in North Virginia. This is where my video is hosted, and I want to watch it. So if I connect to my Netflix client and I start the movie, basically what it does, well, over the internet, so that's the internet. Over the internet, little Carl will request for that video. And typically what Netflix would do is then start streaming that video back to me over the internet. Problem is, I'm in Australia and the video is in North Virginia. So there's a huge distance between the source and the destination. So therefore, probably high latency. So what's going to happen is I'm going to start watching the video and it's going to stream it for a while. Then it's going to stop and it's going to start loading the next piece. Then I'm going to watch it. It's going to resume. And then it's going to stop again, load the next piece, and so on and so forth. It'll constantly do that. We will constantly buffer the next piece, and you'll see those never-ending arrows constantly. So it is a buffering issue. You will buffer that video constantly. And it's awful user experience. You want to avoid that. What if I could bring my resources closer to my users? Well, for that, I would need what we call a content delivery network. Or if you wish, a CDN. Well, lucky us, AWS has its own CDN service, which is called Amazon CloudFront. So what is CloudFront? It's exactly that. It's a content delivery network that leverages edge locations. Edge locations are additional data centers that are independent from regions and availability zones. Actually, they are scattered all around the world in most major metro cities, even in cities where there's not even a region around. All right? So they are really independent from regions. It's another set of data centers. However, in regions, there are also what we call regional edge caches that acts as the same thing for our content delivery network. It does the same thing as an edge location. So overall, we've got over 300 points of presence around the world. So back to my scenario here. Little Carl asks for a movie. But now Netflix is using our CDN, CloudFront, uses our content delivery network. So when I'll request that movie, CloudFront will first look where the source is. All right, it's in North Virginia. Then it's going to look at all the other copies that are available. Is there an edge location closer to me that has that copy? So let's say there's an edge location in Australia. Actually, there are 6 in Australia. So there's one closer to me in Australia. There's an edge location there, but it does not have a copy of that movie. So automatically, CloudFront, through the AWS backbone, because all edge locations are also connected to the AWS backbone. It doesn't go over the internet. So it's going to start copying that movie from here to there. And it's a fully optimized process. As soon as there are a few bits copied, then it's going to be able to start streaming the video to the user. Of course, that piece here will be over the internet, but it's a lot closer. There won't be too many hops to go through. So therefore, there won't be high latency. It's going to be real quick. So I'll avoid that buffering issue I initially encountered. So much better user experience. And in edge locations, you can cache all sorts of things. You can cache all static assets. Again, videos, website images. You can cache website pages. You can even cache dynamic content. Let me explain. Let's say that source here is dynamic. Well, you could set a refresh frequency, which would push out those changes to the edge location. So when your user is asking for to reach that resource, it'll have the latest copy of it, the latest content for dynamic content. And it's something cool as well. Let's say there's another user later on that wants to watch the same movie. This time, CloudFront knows that the source is here, but there's a copy that is closer to that user. And it'll right away start streaming that copy. So all fully optimized, really intelligent content delivery network. Pretty cool stuff. All right? So that is what CDN is. All right, Let me go back here. All right. So now you've got resources all around the world. How do you publish that to your users? Well, for that, you will need a DNS service. Our DNS service is called Amazon Route 53. Sorry about that. Of course. Hold on. And thank you. Amazon Route 53. That sounds like an exotic name. Why Route 53 for that DNS service? Where does it come from? Route 53. Anyone has an idea? Yes, Joe, the port. Absolutely, Alexander. Yes. Because when you do what we call a DNS lookup, those DNS requests are made over port 53. So this is why these guys came up with that kind of cool name. I think it's cool. Route 53. It sounds really cool. So it is a DNS service. So what is a DNS service? Well, when you reach for a resource, you use a specific URL and you type it in into your web browser. What you're trying to reach is not actually a URL. What you're trying to reach is a resource that is identified using a public IP address. Well, what is that public IP address? That's what you need to know. And basically, the DNS service is there to help you resolve a URL into an IP address of a system to reach it. So Route 53 is our DNS service. So not only does it answers to DNS requests, and we'll translate that, but I like to refer to it as our DNS service on steroids. It does a lot more than just DNS resolution. First, you can buy DNS names directly from us. All right. You can manage your records and your zones. Of course, you can do that. You can also use all sorts of optimized routing options. So, for example, you could go with latency based, which means you'll always receive the IP address of the resource with the lowest latency based on where you're at. So therefore, probably a better user experience. It can also use geolocation, geoproximity, which means if you've got to deal with compliance requirements where the user must stay within a certain country, well, you can easily achieve that with Route 53. Of course, you can use that for failover as well. So you've got an environment deployed in one region, an environment deployed in another region. If something happens with your first region, you can fail over to the other one. Of course, you can do that. You can also use weighted routing. What is weighted routing? Well, you give a weight to your route. So let me give you a good example. You've got a website, and now you want to release a new version of it. But you would like to test it. You don't want all your users to go to that new website. You want to test it first. So you would like a smaller subset. Let's say you would like 10% of your users to use that new website. Well, you can configure Route 53 to grab 10% of the incoming requests and route those to the new site and leave the remaining 90% to the old site. So we call that a canary deployment. So you test it first a bit with a smaller group of people. If it works well, then you can reconfigure Route 53 to then grab the remaining 90% and send it to the new website. Or if things go wrong and you would like to fail back, well, you can easily grab those 10% users and bring them back to the old site using Route 53. All right? Pretty cool stuff you can do. All right. Next topic, databases. Another important topic, right? So, as I mentioned earlier on, information is the most valuable asset. It's either stored in storage, and we've already covered storage, or it is stored in a database. That's what we're going to cover now. So, before we talk about databases, you first need to understand which type of database you need. And there are two types out there. There are the SQL databases, or if you wish, the relational databases. So those you can query using a structured query language or a SQL language if you wish. And you can run those complex queries where there's a bunch of joins and things like that. So really performant. You can really get the information you want with those complex queries. So that's one type of database. If that's what you need, and those are the schema of such databases is pretty well structured. So you've got columns with column names, and then you've got rows, which are basically your entries. So for example, you got a column called product name, and then a column called product ID, and then a column called price, and so on and so forth. So you get the idea, and then you've got your entries, which will contain the name of the product, its ID number, and then the price. So that's really well structured. If that is what you need, there is a service called Relational Database Service, or RDS. I already mentioned that. So you can either spin up an EC2 instance and install the database engine in there, or you could go with that fully managed service. So all the tasks, tedious tasks that you would have to do if you were to do it on your own, such as replication, backups and restores, updates, and patch management, well, all done by AWS in that case here. So they'll replicate the database for you. There's going to be a main database and then a replica database for most of them. They'll take care of the backups, the recovery. They'll take care of everything. The only thing you need to do is copy the data over. And it supports several major vendors: PostgreSQL, MySQL, MariaDB, Oracle databases, and Microsoft SQL servers. All right. So those are running on EC2 instances managed by AWS. So you simply need to point your application to that new server. No need to rewrite your existing code, because it really is a SQL server in the backend or an Oracle server in the backend. All right. I mentioned those, but there's one that I didn't mention yet. Amazon Aurora. What is it exactly? Well, Amazon Aurora happens to be our homegrown relational database service. It really is an RDS service, but the vendor is ourselves. It's Aurora. It's made by AWS, and it supports two types of databases: MySQL database and PostgreSQL compatible databases. But the huge advantage about Aurora is the way it is designed. So first, it will provide you with more, with better performances and scalability, because it has more replicated copies, and those are used as well for as read copies. So you're going to achieve a much better performance. In fact, it's so performant that you'll achieve 5 times the usual performance of a MySQL database. You're going to achieve 3 times the usual performance of a PostgreSQL database. All that for 1/10 of the price. It really is cheap. So that is something important to consider. As soon as you need a relational database and you can migrate to Aurora, you're going to save a lot of money there. So think about it, all right? It's more performant and it's cheaper. Pretty cool. But what if instead what you need is not a relational database? What you need is what we call a NoSQL database, or a non-relational database, where the structure is not as well defined. Well, for those, you cannot query using those complex queries. You can only use simple queries. But it is known to be so performant because it is not, it doesn't have that overhead to the structure of the schema. So it really is useful in those use cases. So the advertisement industry, the gaming industry, and IoT are really huge fan of NoSQL databases. And the NoSQL databases, we also refer to key value pair database. You may see that somewhere. Well, we only have one service for that, DynamoDB. Quite simple. Our homegrown NoSQL database service. So performant, and I'm not joking, that it will provide you with single-digit millisecond latency at any scale. No matter how big it is, you'll always have that single-digit millisecond latency. To give you an idea, In 2019, 3 years ago, Amazon held its Prime Day event, which lasted 48 hours. So in 2 days, in 48 hours, AWS received 7.11 trillion requests, which peaked at 45.7 million requests per second. 45 million requests per second. No hiccups. Was working real fine. All right. So that's DynamoDB. If that's what you need, we have a service for that. But yet again, remember, it's a NoSQL database. It's not the same type of database as SQL, Microsoft SQL or Oracle. Those are relational database. So those are different. It depends on what you need. And if you need to improve performance furthermore, there's also another service that is pretty interesting, which is called Amazon ElastiCache, which basically provides you with a caching layer that you're going to put in front of your databases. And when people are running queries, all the most frequently queried pieces will be cached into that caching layer. So on subsequent queries, the information is grabbed from that cache, which makes it a lot more performant. And that service is based on two technologies that we support, either Redis or Memcached. So if you are knowledgeable about those technologies, just know that we support both, and you can configure those the same way you can traditionally do that on premises. All right. So pretty cool thing. Again, some very good use cases for that where you really need performances. All right. Now let's get into the security module. For security now, we already covered some security services in the networking module. All right. So we saw some security controls at the network layer. Now let's talk about some other security services at other layers. So let's begin with our main security service. Our main security service is AWS Identity and Access Management, or IAM. That service allows you to granularly control access to your AWS resources and services. You can really define in a granular way not only what can user access, but what they can do with those resources. It really is granular. All right. And we do that using typical concepts in authentication systems, such as users, user groups. We can even provide temporary access. So let's say you've got a user that needs to replace someone that goes on vacation. So every morning you would like that person to kind of assume the role of the other person temporarily. Well, you could use what we call roles. That is there just for that. That will allow you to assume a temporary role with specific permissions that will override your usual permissions for the duration of the time you assume that role. Once you're done, then you'll get your usual permissions back. All right. We can even use that for services, AWS services that need to access another AWS service, and you need to provide access and permissions. So in that case, for example, an EC2 instance that requires access to an S3 bucket to go and read some data. Well, you could have that EC2 instance assume that role that will allow to do that. All right. So we've got that. It also integrates with external identity providers, such as Active Directory. So you can do an integration that will allow you to then use single sign-on to connect your AWS environment. All right. And that service, Identity and Access Management, you don't need to deploy any servers or components. All right. So you don't need to deploy domain controllers or things like, no, you don't need to do any of that. With Identity and Access Management, it's a fully managed service that includes all the high availability you need, scalability that you need. Whether you want to create one user or 25 million users, it's not a problem. All right, will scale, will be able to achieve that. All right. It also supports multi-factor authentication. So, you know what those are, right? Multi-factor authentication. It's that annoying thing that they added years ago where now when you want to log into a resource, a website or something, not only do you need to provide your username and password, but you also need to provide on top of that a code that will be sent to you. Well, we do support that as well. All right. So that's identity and access management. And sorry about that. There are some principles that we would like to share with you. So when you sign up for an AWS account, it'll return to you an account ID number. All right. So that will identify your MFA, this magic thing customer don't understand. I love it. That's true. So when you sign up for an AWS account, they will give an account ID to you. So that represents your account. But also they will give you a root account. That root account has all privileges over your AWS environment, all permissions possible. What we recommend is that you use it to define your billing information, such as the credit card to use, to define the email address for that root account, and to define the support plan to use. And then what you should do, you should create another IAM user with enough permissions to create additional IAM users. So basically, you can create kind of an IAM admin user. And then you lock down the root account and no longer use it. You only use it when you need to either change billing information, support plan, or the email address. Otherwise, you do not use that account anymore. And enable multi-factor authentication on it. Then that IAM user can then create all the required IAM users, groups, and roles. All right. And you can even provide temporary security credentials. I've explained that, right? With roles, for example. So those are principles around IAM. All right. Now let's talk about encryption. Because yes, you may need to encrypt some data. And we've got about over two dozen services on which you can enable encryption. Some example, when I create an S3 bucket, I can enable encryption on it. When I create an EBS volume that I attach to an EC2 instance, I can configure encryption on it. Great. You know how encryption works, right? It mixes the bit pattern of a file to render that file unreadable. And it does that by using what we call a cipher. So it's going to use a cipher to encrypt that data. Anyone happens to know what the cipher AWS uses? What is the cipher that AWS uses? Just curious. Anyone knows? Good question. Close. Great, Joe. That's exactly that. Actually, that's the encryption key we use now. No, it's AES 256. All right, that's what we use. And basically, we mix the bit pattern using that cipher based on a key it will generate. And only when you have that key can you actually read and decrypt that data. So it's going to create an encryption key, a cryptographic key. Who manages those keys? It could be AWS. But it's a big problem right there, because that means that AWS theoretically has access to your data. Because if we grab that key, we could actually open up that data and read that data. Of course, they would never do that, but theoretically, they could. So this is why, to be compliant in heavily regulated environments, this is why there is a service called AWS Key Management Service, or KMS, that allows your customers to create and manage their keys. Not AWS, your customers. So only your customers can manage those keys. And it fully integrates with CloudTrail. So whomever access any data using one of those keys, it's going to be tracked. It's going to be traced. So you'll know exactly who did what with the data. So it complies to all those requirements in regulated environments. All right. So key management service, KMS, which allows you to create those keys. Now, let me talk to you about AWS Shield. Pretty cool service that you will love. And I'll explain to you why. When you are publishing resources out there to the open world, those will become what we call well-known URLs. And as soon as you've got well-known URLs, guess what? You're going to be under attack. You're going to be under attack from hackers trying to do what we call a denial of service attack. What is it exactly? It is a case where you've got that hacker on a Saturday night that does not know what to do, and therefore decides to send, using his computer, a bunch of requests to your well-known URL. So maybe your website that runs on an EC2 instance, for example. So he's going to send requests that may seem legitimate, but he's going to send so many of them that it's going to start impacting the performances of your EC2 instance. And that's a denial of service attack. If he doesn't have anything to do, he might even build a virus that will spread and will then leverage several systems to send a bunch of requests. This could literally take your resource down, your website down. I'm going to give you a very good example. There is a company here in the Quebec province in Canada where I live. Basically, it's the equivalent of a state in the United States. So in the Quebec province, the Quebec state, if you wish, there is a voice over IP company for which the IP addresses of all their voice over IP servers was leaked at some point. So what hackers did, they started hammering all the voice IP servers with DDoS attacks and took all of them down. And what they did, they sent a message to the company. Listen, if you want us to stop, you got to give us a ransom. So now they start doing the exact same thing as ransomware, but instead of encrypting your data, now they take your resources down through DDoS attacks. That is painful. All right. So this is why as soon as you publish resources and they become well known, I promise you, it's not a matter will you or won't you be under attack. You will. It's a matter of when. I promise you. All right. So to protect against such DDoS attacks, AWS has a service called AWS Shield. AWS Shield guards against those DDoS attacks, will mitigate those DDoS attacks. It comes into two flavors. AWS Shield Standard, which is free of charge for every customer. Even if you just use the free tiers, it's in there, ready to be used. And this will prevent most common layer 3 and 4 DDoS attacks. Not only will it monitor the flow of traffic, it uses machine learning, artificial intelligence, so it will be able to easily detect those layer 3 and 4 DDoS attacks and will mitigate those for you. That's pretty cool. And that's free of charge. But what if you deal with more sophisticated attacks? Well, in that case, you could subscribe to AWS Shield Advanced. With AWS Shield Advanced, which, by the way, this one has a price tag, which is about $3,000 a month. That may seem like a lot, but hold on. What does that include? Well, first, it includes an enhanced engine to detect those DDoS attacks. So more sophisticated engine that will be able to detect those more sophisticated attacks. And will mitigate those. But, if it cannot mitigate an attack, it'll notify our security team. So you've got access to a 24/7 response team. So these guys will roll up their sleeves and will start working on mitigating the attack right away for you. So that means you now have a full security team working for you. And if there are costs incurred by that attack, think about it. These guys are hammering an EC2 instance here in this example. That EC2 instance could be part of an auto-scaling group. And therefore, it could spin up a bunch of additional instances because that is seen as an increase in demand, right? There's a lot of connections against that EC2 instance. So that could spin up a bunch of additional instances. Well, if you've got Shield Advanced, all the costs incurred by that attack will be nullified. It basically includes an insurance against increases in cost due to DDoS attacks. Very good question, Lucian. So that's 30 per month per EC2. No, I think it's for the entire service. But anyways, I really love your question. But my answer is, what would you answer to Lucian people? What would you answer to Lucian for that question? Let me type it in. AWS.amazon.com/shield. You're going to get to the service page. If you get to the service page, what should you be looking for? A pricing tab, because you're asking questions about pricing. Is it a paid service? Well, of course, it could be a paid service for the advanced version. So that's going to be explained in that pricing page. So that they'll tell you if it's just for one instance or for the entire service, which I believe is for the entire service. And it will explain what it includes and what it does not include. All right. So just wanted again to remind you on how to find that information when you're on your own. I try to help you, try to teach you how to fish, sort of. All right. So AWS Shield, pretty cool service, pretty useful. Now the next service, or bunch of services, I should say, group of services, are around management. So now that we've seen the services that we can use for our solution, but now we need to manage that solution. So what are the services available out there for us? Well, let's begin with our main monitoring service, CloudWatch. Before I get into that, just give me 30 seconds. I'll mute myself because I need to blow my nose, and then I'll be back with you in a few seconds. Oh, geez, that cold. All right. Yeah, so CloudWatch is our main monitoring service. So when you publish resources, for several services and resources, there are metrics that are being collected. Remember my example for EC2 instances, we are collecting metrics every 5 minutes. Metrics around the CPU usage, the network usage, the number of connections received by the EC2 instance. So a bunch of metrics. And those metrics, then you can do a lot with that. You can either visualize those, and there are several ways to visualize that. So first, there are dashboards built-in dashboards that are populated with that information. So if I go into the EC2 instance dashboard, I'm going to see information about my EC2 instances. Well, that information comes from CloudWatch. But there's also a centralized dashboard, if you wish, CloudWatch dashboard, where you'll see from a single dashboard a glimpse of what's going on in the environment. All right. So that centralized dashboard can be customized as well. So based on your role, based on what you're looking for, you can customize that to see exactly what is relevant to you. But what is most important about that service is that you can then create what we call CloudWatch alarms or CloudWatch alerts. What are those? Simple. Based on those metrics, you can then create an alarm. So let me give you an example. You could say, well, that's a very, very critical EC2 instance. So if the CPU usage ever goes over 80% for that EC2 instance, I want to be notified. CloudWatch alarm. I just create a CloudWatch alarm that will notify myself. Yeah, but my manager, who also has concern about that EC2 instance, would like, if the situation persists for more than, let's say, half an hour, would also like to be notified. Another CloudWatch alert. And I'm talking here just about notifying people, but you can actually do a lot more. You could trigger auto-scaling activities. It's the same as an auto-scaling group, basically. You're just mimicking an auto-scaling group. But you could do that. You could launch a Lambda function to react to something. There are so many things you can do. Again, give me the use case, what you try to do. I'm going to find the solution, how to do it for you. So keep in mind that you can trigger and initiate about anything you want from that alert. So instead of reacting to events manually, so notify somebody that's going to wake up at 2 a.m., will first grab a coffee to try to wake up, and then connect to the laptop, then connect to the environment, investigate, try to figure out what the problem is, to then mitigate the problem. What if you can actually automate all that? That's going to provide you with a much quicker response to an event. Much quicker. What I like to say, whatever happens in your environment that you think may happen again, and you know how to resolve that, how to mitigate that, why not creating an alarm and react automatically to that event? Take time to do that. That's going to save you time at the end. All right? Know that CloudWatch not only monitors or collects metrics about resources, but also it can monitor log files. Can monitor log files, AWS log files, such as your VPC flow log or your DNS logs, but also any sorts of logs. So even your own application logs, you could monitor with CloudWatch. And then you can set alarms. You could say, if you encounter the word error more than 3 times in 5 minutes, alert me. Do something. Pretty cool. So more and more, you'll be able to start automating reaction to events. And that's what you should try to do, right? Remember, one of the first best practices that I've talked about, do stuff as a code as much as possible. You can even create alerts for billing, by the way. Once you reach a certain threshold, let's say for your budget, well, start sending me notifications. You can do that. Pretty cool. All right. Next service that I want to talk about is a service that I don't like it. I love it. It's AWS CloudTrail. What is it exactly? What is CloudTrail? CloudTrail, I like to refer to it as Big Brother. It is that guy over your shoulder watching everything you're doing and then taking notes. I'm joking a bit, but that's exactly what that service does. So when you interact with AWS resources and services, whether you use the AWS Management Console, or you use the command line interface, or you use the software development kits or SDKs, no matter which method you use, behind the curtain, those are all API calls. That's basically what you're doing. You're doing API calls because our cloud is API call based. So for each and every of those API calls, CloudTrail collects a bunch of information, such as who made that API call. Oh, it's Carl. What was the API call? Created a user called Mary. Okay. Some information about the timestamp, the date, where it originated, so the IP address. Was it through the management console? Was it through the command line interface? And actually, an entire copy of the API call, which is JSON based. So you're gonna really see that call printed on screen. So that tool is awesome for a couple of things. First, compliance. Compliance, really, compliance, security, all that type of requirement where you need to make sure to capture what everybody's doing in the environment. CloudTrail is your tool for that. But also me, personally, what I like it for, troubleshooting. What if everything was running fine in my environment all the way up to 1 hour ago? Starting 1 hour ago, everything is not working properly anymore. What happened? I could start calling people, or what I would most likely do is get into the CloudTrail dashboard and look at the most recent events, maybe the events that happened in the last hour. Oh, Carl changed this. I'm going to call Carl. Carl, why did you do that? Well, I tried to achieve this. Okay, I get it, but it doesn't seem to work as expected. So let's revert it back because we've got traces. We know what it was before. So we can revert it back and then we'll investigate. So that's an awesome troubleshooting tool. All right. So CloudTrail. Does CloudTrail also work with Kafka Streams, MSK? Listen, Matthew, I'm not knowledgeable about either Kafka Streams or MSK. So here's what I'm going to do. I'm going to capture your question, and I'll do some research tonight to properly answer that question in a follow-up email. I'll never be pretentious enough to tell you that I know everything there is to know about AWS, but I'll be pretentious enough to tell you that I've got pretty good contacts that can get me those answers. All right. Another service that we've talked about, CloudFormation, right? So pretty cool service that will allow you to deploy an entire stack of resource following a pre-configured template. So instead of launching EC2 instances and then attaching EBS volumes to it, and then maybe adding S3 buckets for the backups, you could do all that manually. You could even script all those pieces, or you could just use a CloudFormation template. Go in the designer, say, I want an EC2 instance, I want 2 EBS volumes attached to it, one that size, I want an S3 bucket, and boom, I'm done. It's going to deploy it for me, right? Of course, there's a bit more parameters to set than what I just said, but that gives you a pretty good idea. And again, what is important about that is that you can then save those templates and reuse them as needed to reproduce similar environments. You can even use inputs from users. So for example, let's say you want to publish an environment in a different region in the world. Well, maybe you would like to use the exact same CloudFormation template each and every time you deploy in a new region, but you would like to be able to let the user define the region and maybe the availability zones to use. So in that case, that may be one or a couple of information that they need to input. So you end up with one CloudFormation template that requires a couple of inputs when you use it. So that way the user will select the right region. All right, so you can even do that. What else? What else? I think I've covered everything when I initially talked about CloudFormation. Yeah, imagine CloudFormation. I told you, you can actually clone an environment. So you can clone, or if you wish, create a template for an existing environment so that you can then easily recreate that environment. Think about a production environment that you would like to clone for development. So you could use CloudFormation for that and replicate that architecture in just a few minutes. All right? All right. Another important service, especially for you dealing with large customers. So when you start talking about hundreds of EC2 instances, dozens of EBS volumes, if not hundreds of EBS volumes, and a bunch of VPC configurations. So that's a lot to configure. That's a lot to maintain. That's a lot to keep in your inventory. So how can you build an inventory of all those resources? Well, luckily, we've got a service which is called AWS Config. AWS Config is an awesome service that first will create an inventory of all your resources. So that's the easiest way to build that inventory with AWS Config. Not only that, but then it'll also capture all the configuration parameters of all those resources. And then it's up to you to decide what you want to do with that. Typically, what people are doing, they're creating what we call AWS Config rules. And AWS Config will compare the current configurations of your resources with those rules. So for example, if you've set a rule that for each Amazon S3 buckets, I do not want open access. I want all those buckets to be secure. Well, if at some point somebody changes an S3 bucket and make it open access, AWS Config, which scans the environment, will notice that. And right away in the AWS Config dashboard, you'll see an entry about that finding. Oh, you've got an S3 bucket that has open access, and it goes against your rule. And those rules could either be your rules that you've created to meet your compliance requirements, but those could also be provided by AWS to meet AWS best practices. So that's pretty cool. You could grab AWS's rules and or your rules. So you could combine with your rules as well. So pretty powerful. That way you ensure that all your resources are configured exactly the way you want those to be configured. So you can quite imagine that in those heavily regulated environments, that's an awesome resource. But also for troubleshooting purposes, because you can easily see that, oh, this one does not meet our configuration rules, so therefore that's why we've got a problem there. And you can actually revert back to what it should be. All right, so pretty cool stuff you can do with AWS Config. Now, before our next break, I think so. Let me just see what, yes. One last slide before the next break. Anyone of you ever heard about the AWS Marketplace? The AWS Marketplace. Anyone of you have ever been to that site? Mohammed, would you be able to revert the setting from CloudTrail? Or is it just like event logs? No, Mohammed, that's going to tell you what happened. Then if it's, for example, something in EC2, you would need to go to the EC2 dashboard and revert the setting back. But at least you'll know what that setting was. And that's the goal of CloudTrail. All right. Good question, Mohammed. However, CloudTrail, when it notices that, you could actually set an automation. You could define to run a Lambda function. And that Lambda function could actually address that issue. So again, you can automate. Always think that you can automate stuff. Really important. All right, so back to the marketplace. So Rob says, yes, you've been there already. Anybody else? Ever been to the marketplace? Oh, you did? Awesome. So what is the marketplace? Well, the AWS marketplace, I like to refer to it as the app store of your smartphone. Because when you when you go in the app store, what does the app store do on your phone? It allows third parties to publish applications that can run on your phone. Well, the AWS marketplace does exactly that. It allows third parties, basically partners like yourself, that are publishing solutions that either runs on AWS Cloud or that integrates with AWS Cloud. So that's pretty cool. Let me actually show you the marketplace. Give me a minute. I'll even share a link with you. Although you'll receive a copy of that slide deck, so basically you'll receive that link anyways. But here it is. So as we can see now, as we speak, there's over 10,000 solutions published on the marketplace. Can you imagine that? That's a lot. All right. And you can filter out for exactly what you're looking for, or you can browse categories, or you can explore by industries or use cases. So there are several ways you can look for a solution. So let's say I want to browse a category. Let's say I'm looking for security solutions. I'm going to click that. And as you can see, you can filter furthermore. So let's say, in my case, I'm a huge Fortinet fan. So I'm not doing any marketing for them, by the way. I just needed to pick one, and I picked these guys. But let's say I'm looking for something made by Fortinet. And I can then see here that they are currently publishing 45 solutions on the marketplace. I can go through those and see what I'm looking for. So, for example, oh, that's what I need. I need the FortiGate next generation firewall. So I will deploy their firewall on AWS Cloud in my VPC to protect my VPC resources. And it will also integrate with my portal to manage those firewalls. So let's say that's what I'm looking for. So I'm going to click this here, and what you'll an overview that will tell you what that solution does, and will explain what are the benefits. But what I want to draw your attention to is the pricing section. If I click there, it's going to bring me to the pricing section where I first need to select a region, because yes, prices may differ between regions. So it may cost you more to run something in a specific region than another one. That's expected. So you're going to pick the region you want to deploy into, and then you can look at what they require. So here, for example, they recommend running that on a C5X large virtual machine. So there you go. It requires a virtual machine. That's the only requirement. It's going to require an AWS virtual machine to run. And they recommend a C5X large. So if I stick to that, I stick to C5X large. Then what they're telling me is that if you stick to that, to run their software, their FortiGate next generation firewall software, it's going to cost me 85 cents an hour to run that. And then it needs to run on that C5X large machine. So what are the infrastructure prices incurred? In this case here, just one EC2 instance. Well, it's going to be 17 cents per hour for that EC2 instance. So basically what they're telling me is that it's going to cost me just over $1 an hour to run that solution. Now, you do not need to turn to Fortinet to pay them for that software and then turn to AWS to pay them for that infrastructure. Think about customers that are using maybe half a dozen or a dozen solutions from the marketplace. That would mean half a dozen partners they have to turn to and pay. Well, the same as the App Store on your phone. You simply receive one single bill from AWS. That will be itemized. You will see those entries for the FortiGate Next Generation Firewall software. But you'll only pay AWS, and AWS will turn to those partners and pay them for you. All right? So, pretty cool. All right. So that wraps up Module 3, leaving us with Module 4. Now, we're done with the big module where we go over all those services. Now that leaves us with that use case I was talking about, where we're going to go over a fictive customer story, but from which we will then build a solution to help them. And we're going to do that together. All right? So we're going to take a break before that last segment. Open text content service. I would have to look into that. But open text, depending on what you mean, open text content service, because we've got, I'm just copying the questions at the same time. Hold on. Yeah, let me read into that. Because for me, open text isn't it like an open source word editor, if you wish? So I don't know exactly which open text content service you're referring to, because we do have some machine learning services such as text to speech, speech to text, things like that. So I don't know if it's really what you were referring to. So let me read on that to further understand your question. Thank you, Mohammed. All right. Okay, so we're going to take, let's say, a good 10 minutes, because right after we're going to start the last stretch, which is a bit longer, but a lot more fun. So we're going to take a longer break this time. So how about 10 minutes? All right. All right. Talk to you soon. All right. Hope you had time to maybe grab something to drink. And for those of you who are really, really late, maybe an alcoholic drink, because now you're allowed. You're outside work hours. But I am not allowed, so I'm going to stick to my Coke Zero at the moment. So, first, I want to make sure you guys still hear me. I know that I'm annoying with that, but I want to make sure, because it happened to me more than once when I came back from break. Awesome. All right. So now we'll resume with the last module of this course. So now we're done going over all those services. So I know it's probably less interesting having to go over those services and all, but we brushed an overview of what those foundational services are so that you can then start leveraging those to build a solution. Of course, in the Cloud Practitioner Essentials course, we go in greater depth into those services. And again, we do demos and things like that, and even cover additional services. not in this course here. It was just an overview, and I think it is more than sufficient for what we're going to do in this module here. So, before you design, before you design a solution, you first need to ensure that the solution you will design will meet all AWS best practices, especially in regulated environments where there's compliance involved and things like that. You certainly need to meet AWS best practices. How can you achieve that? Well, in order to do so, we've got tools that will ensure of that for you. And that first one I'm going to talk about is what we call the AWS Well-Architected Framework. What is the AWS Well-Architected Framework? Well, it is a framework that was created by our professional services out of their years of experience in migrating customers to AWS Cloud. So they build a framework that will ensure for you that all the areas are covered and are meeting best practices. So basically, they'll ensure that you didn't leave any stone unturned. And they do that through a set of questions and design principles. So you'll see there's a bunch of questions and design principles. And by the way, there is an half-day digital course that explains everything about the cloud adoption, not the cloud adoption, but the well-architected framework. I'm going to share some links with you, but again, it's going to be part of the follow-up email as well. But those are pretty interesting links that will explain what the well-architected framework is. And again, it's done through a set of questions and design principles that can be grouped into 5 categories. Those categories, we call them pillars. So it's based on 5 pillars. And those pillars are operational excellence, security, reliability, performance efficiency, and cost optimization. All right. So let's go over those in greater depth. So let's begin with the operational excellence pillar. This one is about the ability to run and monitor systems, to deliver business value, and to continually improve supporting processes and procedures. It's not just monitoring system, but also continually improving the processes. And that pillar can be divided into 3 areas: the prepare area, the operate area, and the evolve area. In the prepare area, this is where you need to understand the business and customer needs, which will allow you to decide priorities or design your architecture for operations and readiness. Then you've got operate, which is all about how to operate the workload. So you'll need to understand operational health, and you'll do that most likely with metrics. But then you'll also need to respond to events. So automated as much as possible, for example. And then evolve, because again, everything continues to change. So you'll learn from experience, you'll share those learnings. That's exactly what that pillar is about. So, as I told you, it is based on questions. So we're going to look at an example of those questions here. So let me grab my pen again. So this one comes from the prepare area of the operational excellence pillar. So the question is, how do you determine what your priorities are? And then you'll need to answer that question through a set of predefined answers. And based on those answers, the system will know if you forgot something or not. And I'll actually show that pretty soon. If you do not clearly understand a question, luckily there is a bit more context added to it. Well, everyone needs to understand their part in enabling business success. Everyone needs to have shared goals in order to set priorities for resources. This will maximize the benefits of your efforts. So that gives a bit more context. And there's also a best practice on which it is based. So the best practice, or the design principle, or whatever you want to call it, states that to implement the minimum number of architecture standards for your workloads. Balance the cost to implement a standard against the benefit to the workload and the burden upon operations. Reduce the number of supported standards to reduce the chance that lower than acceptable standards will be applied by error. Operations personnel are often constrained resources. So that's the best practice on which that question is based on too. All right. So that's just to give you an example. But there are, again, several pillars, 5 of them. So let's keep on going. Security. Well, of course, security questions focus on the ability to protect information and systems. And this covers 5 areas of concern. Who can do what with identity and access management? Detecting security events with detective controls. Protecting systems with infrastructure protection. How about confidentiality and integrity of data? And responding to security events. So this is what the security pillar covers. So, a good example. How do you respond to an incident? That seems like a fairly simple question, but you'll see with the answer choices, it's a bit more complex than we think. Well, I'm going to show that soon. So again, a bit more context and the best practices on which it's based. Reliability focuses on the ability to recover from failures. Not only recover from failures, but also to meet demand. So you need to dynamically acquire resources to meet the demand. All right. A good example, how does your system withstand component failures? Good question. Performance efficiency, which is the ability to use IT resources efficiently. So have you selected the right resource type for computing, for storage, database, networking? And if we talk computing resources, have you considered serverless versus maybe EC2 instances? Because that could drive performances. Databases, remember? Relational versus NoSQL databases. NoSQL databases are more performant, but maybe you need to be able to run structured queries. So, depends on your need. And in order to improve performances, well, you'll need to do a lot of benchmarking and document that. So you're going to do load tests to validate if your changes are actually helping or not. Because if they're not, you should go back to what it was and go with what really improves your performances. So you will need to do a lot of benchmarking and document that. But also you're running resources. You need to properly monitor those so that when performance degrades, you are aware and you can take action before it actually impacts the customers. All right. Now, a good example. How do you select your database solution? Another good question. Cost optimization, which is the last pillar. It's all about the ability to avoid unneeded costs, or basically to do more with less, right? So you'll need to evaluate if the resources you selected are cost effective. So should I stay with on-demand EC2 instances, or should I consider reserved instances, or even spot? You need to match supply and demand with approaches such as auto-scaling of EC2 instances, for example. And you need to control and understand where your money is being spent So you can use several tools that we have that will allow you to properly analyze your costs to further optimize those. Yes, auto-scaling. Auto-scaling is actually useful for two pillars. For this one here, but also this one there, because this one, cost optimization, what if there are resources you no longer need? Well, the system will automatically scale in. So it's great to scale out, but most importantly, it's great to scale back in. So you avoid those costs for idle resources. So that's why sometimes one solution, such as auto scaling, can actually help two pillars. All right. So an example of a question: how do you evaluate cost when you select services? Those all seem like simple questions, but we'll see what it looks like. And there are also, on top of questions, there are design principles, and those you will learn at some point. And even the questions, the more you're going to use that tool, the more you're going to learn about those. It's going to become a second nature. One of those design principles, enable traceability. Log and audit all actions and changes to your environment. Automatically respond and take action. From which pillar do you think it comes from? Enable traceability. Log and audit all actions and changes to your environment. Automatically respond and take actions. From which pillar do you think it comes from? If you remember those pillars, of course, we just covered that. So, Natalia is saying security. You guys agree? Just want to see if operational. Alexander? I want one more answer. One more, please. Somebody else. It's all of them. Well, the answer, Natalia, you got the right answer. So enable traceability to log and audit all actions. It's security. It's security. You need to ensure of that. So good tool for that, CloudTrail. So you log and audit all actions and changes to your environment. So absolutely, Natalia, you got it. All right. Great, guys. So you, as a partner or a solutions architect, what do you bring to the customer? What's your value proposition in regards of architecting a solution? Well, because you know about the well-architected framework, you know about the well-architected tool that I'm going to show you pretty soon and how to use it. You ensure that you apply a consistent approach to your architectures. So customers are sure that you bring standards and a consistent approach, and you fully understand and reduce risk in their architecture because you know those best practices. And of course, each and every time you learn something new, that's going to influence your future architectures, which, in the other hand, will accelerate cloud migration for your customers. And you do that using a tool called the Well-Architected Tool, the AWS Well-Architected Tool. And there's a bunch of resources on the Well-Architected framework and the tool. There are white papers specific to the architected framework, or the pillar specific white papers as well. There's online training, as I mentioned, and some additional resources. But even though I told you this class does not have any demos, well, guess what? I lied again. Because I like lying. No, I'm not. I do not. But I want to show you still how to use that tool. So if I go here, and I reach the management console. Hold on, I've probably been kicked out, so let me log back in here again. Give me a couple of seconds. All right, there we go. All right, so this is the AWS Management Console. All right, so that's the main dashboard when you log in which you can add widgets and customize the way you want. But if you're looking for a service, you can either click services here and access the entire list of service, or you can actually maybe look at the recently visited services. Maybe the one that you're planning on using is there because you've used it recently. Or what I like to do, use the search bar and type in the service name. So in this case here, we're looking for the well-architected tool. It really is a tool in the management console. So I strongly suggest that you sign up for an AWS account if you haven't done so yet, but I guess you all did already. But this gives you access to that tool. So I'm going to click it. And for those of you solutions architect, I strongly recommend that you familiarize yourself with that tool and you get good at it, because you'll see that's going to help you a lot. So I'm going to click. You can see here it brings the dashboards. You could be either under dashboard or workloads. Either way, you can just click workloads. You're going to see the workloads you've got. So I've got one already for which I've answered all questions. And it flagged 40 high risks and 12 medium risks. I'm going to define a new workload. So that's exactly what you do. You define workloads. So I'm going to click that. First, I got to give it a name. So that's going to be my test workload. Let's go with my test workload. Got to give it a description. So test. You got to define an owner. Could be using an email address, somebody's name, whatever, but you've got to define an email owner. So I'm going to go with my email address in this example here. Is it for production or pre-production? Let's say it's production. In which region do I want to deploy? And it could be more than one region. So I'm going to go with Canada Central at the moment. But as you can see, you could select additional regions if you wanted to. Optionally, you can provide your AWS account ID. If you happen to have a architectural design of your solution, and you can reach it through a URL, you can simply paste it here. You can choose, you can add information about the industry type of your customer. So maybe they are into, let's say, education. Of course, I like education. And let's say they are higher education and research. Love those universities. All right. So let's say that's my customer. I'm going to click next. And then you got to choose the lens that you want to apply. And in our case here, it's the well-architected framework. So I'm going to choose that lens. And then I'm going to click Define Workload. Now, that brings you to your workload page. Now, you can start reviewing it by clicking this here. Or you can first look at the pillars. So you can see those 5 pillars here. With the default order, you can edit the order. This depends on what is more important to you. So for example, if for a customer, security is the most important thing, you could bring it up in the list. Or if it's cost optimization, you can move it as well. So it really is up to you to define the order. Doesn't do much except for the report that will show you the findings, the risks. They will be ordered in the order of your priority here, right? So that's the only reason why you may want to change that. So you can either start reviewing or click the well-architected framework lens. Either way is good. I'm going to go with this here. And there you go. You will start answering a bunch of questions. I was not lying. There's actually 5 pillars with a bunch of questions. So let's begin with the very first one. How do you determine what your priorities are? We've seen that. How do you determine what your priorities are? If you need more information, you can click the info link, but there's also some more context. Everyone needs to understand their part in enabling business success. We've read that already. If that question does not apply to your workload, you can toggle that switch. and optionally provide a reason why. Maybe it's out of scope, maybe whatever. If it applies, leave it there. Be honest. The more honest you are, the more accurate the results will be. And based on those answers that I will provide, the system will be able to figure out if I forgot something. So if I read that question again, how do you determine what your priorities are? Well, maybe I've evaluated my external customer needs as well as my internal customer needs. Maybe I didn't do any of the rest except for managing benefits and risks. So right away, I can tell you, if I forgot to evaluate those, it's going to bite me back. It probably is something that I forgot to consider that is a best practice. All right. If you need some information about the answers, again, there's the info link as well as some helpful resources for each of those answers, if you wish. All right. And then you can optionally add notes and click next and get to the next question. And you simply need to go over all those questions and honestly answer those questions. Lucky for us, I did that already here. So if I click it, here's what you'll see. So first, you can click the well-architected framework because you want to have the information about that lens. And as you can see here, I've answered 52 questions, and here are the findings. All right, so I'm going to click that. So here, you will see, once it opens up, there you go. You will see my pillars, the questions that I've answered, as well as the findings, the high risks and medium risks it found. And then the next risk to address. And again, it's based on your order of priorities that you've defined. Or if you want to see them all, what you could do, you could go here and click Improvement Plan. So if I want to look at my improvement plan and see what I should work on, there you go. Now you see all the security risks it found, or risks it found. So I can start with the first one, which is, how do you securely operate your workload? So based on what I've answered, the system flagged it as a high risk. And they recommend the following improvements, the following items, such as securing your AWS account. This is because, based on my answers, I probably didn't secure my AWS account. So that's why you gotta be honest about those answers. So, all right, you want me to secure my AWS account, so that's the best practices. I understand that, but how do I do that? Well, simply click the link. Not only does it give you the findings, but also all the required resources to learn how to do it, how to address that. Could be white papers, could be documentation pages, whatever you need. There's even a lab, as you can see here, to practice working with the root account, securing the root account. So pretty cool, right? So this is the well-architected framework tool. And again, I strongly recommend that you familiarize yourself with it, use it. Of course, the first or couple of first designs you'll do, architectures you'll build, it's going to take more time. There's going to be more findings. But as soon as you get familiar with those design principles and best practices, the less findings there will be with each and every iteration of architecture. Because it'll become a second nature to you. So that's pretty cool. It's the first company that I've worked for or product I've worked with where you've got a complete dashboard that tells you all the best practices and the ones you forgot and you should address and how to address that. That's pretty cool. That's useful, especially for solutions architects. All right. All right. So let me bring back the presentation. So we will start architecting a solution on AWS. So there are guiding principles. We went over those already, so I will not spend much time there. Maybe just want to recap. You got to know your customers, not only their internal processes, but also their industry, their competitors, and we'll see that here. Yes, business impacts. Uh, we've covered all that. Absolutely. All right. Yes, that's another important slide. Customers are excited about using AWS services. So you got to be careful. This is why you got to properly manage your scope, because they'll want you to solve all the problems, or even worse, you'll encounter situations where one of my dear colleagues refers to that as management by magazine. And I love that, because that's exactly what it is. You'll have that IT director or whomever, a stakeholder, that will drink a coffee on a Saturday morning while browsing the web, and then they'll read on a service from AWS. They'll get excited, and then on Monday morning they'll get to you and they'll say, we want this, you should bring this in, that's what we need. Well, maybe you as a solutions architect, knowing those services, the ins and outs, and knowing the impacts, you might answer, no, listen, it really is a great idea, great service, but in your case, that might not be the best service for you for this and that reason. I instead plan on using this service that is, I think, better suited for you. So that's going to be your role, because you'll see these guys, they'll get excited. They'll want everything. That's the way it is. Many stakeholders, many goals. Yes, that's something difficult sometimes, where you deal with different stakeholders, and some of them, they preach for their own church, of course. And sometimes the goals of different stakeholders are going against each other. So sometimes this leads to a difficult situation. So you got to clearly identify the stakeholders and their goals. And by the way, it's not covered in that class. It is covered in the Cloud Practitioner Essentials course. There's another framework as well, which is the Cloud Adoption Framework. And this one is there to help customers that have concerns and questions and blockers to move to the cloud. So to ensure that you address all those questions, all those blockers and questions they have, you use an action plan. And that action plan is built out of a work session you do with them, which is called the Cloud Adoption Framework Workshop. All right. That's another course you can also attend. So there are tools available for you in order to migrate a customer to the cloud as smoothly as possible. All right. Yes, identify applications that are candidate for migration. Some of them might not even be candidate for migration. And some of them are low-hanging fruits. So maybe you should focus on the low-hanging fruits first. Some other principles as well. Yeah, we understand all that. All right, so let's talk about the case study. So before you build a solution for a customer, the very first and most important step is to collect information. Collect information in order to identify what are the customer's goals. What are they trying to achieve? Why are they moving to the cloud? Is it to reduce cost? Is it to improve operational efficiency? Is it to... There's several reasons, several goals. So you need to clearly identify that and identify the requirements. And to do that, you will ask a set of questions. Some of them are what we're referred to as functional questions. So for any application, as it mentions here, you need to understand the value the application provides to the customer. How does this application help the organization fulfill its mission? Does it increase revenue? Does it decrease expenses? Does it provide a needed service to stakeholders? So to manage customers, suppliers, regulators, or any other service that they need. So those are functional questions. And typically functional questions, they start with whys. So why is cloud computing the best approach to solve this need? Why is using an application to solve this problem in the customer's best interest? Why should this application be in the cloud? So all those whys typically answers or define functional requirements. And you also have the application functional requirements. So you can break those down into kind of three segments. First, the input, then the application itself, and then the output. And this will define functional requirements. So things like for the input segment, what data does it receive? How much of it does that application receive? From what source or sources? In what format? How often does it receive inputs? Does the arriving data require any manipulation, or is it ready to be used by the application itself? And then you got to look at the application. So what does the application do at its core? What components are involved? How is it encapsulated? Is it hosted directly on physical machines? Is it virtual machines? Is it containers? And how many virtual machines? What's the operating system? What applications are used currently to enable its functionality? Is it made of more than one application actually? How large are the compute resources required? And then all the characteristics of the workload. So the basic web functions. Is it intense floating point calculation? Is it high performance, high responsiveness? And things like that. How many transactions per second? Things like that. And then you've got the outputs. What information gets produced? What or who receives that information, that result? How is data stored? How much data is stored? And for how long? How fast are the outputs needed? So you see, all that is a bunch of functional requirements that are really important to understand. And then we can look at the non-functional requirements, which basically means those are important things, but will not prevent a customer from using their application. But they are still important things. Just think about durability or reliability. Until there's an event, not having high availability doesn't prevent a user from using that application, but what if something happens? So that's a non-functional requirement. A very important nice to have. Not nice to have, but must have. Think about management and monitoring. Performance, scalability, elasticity, globalization, security requirements, documentation. That does not prevent a user from using the application, but that's quite important. All right, so you need to define those requirements. And non-functional questions are typically the hows. So how will the application meet performance, scalability, and elasticity requirements? How is performance measured? How do needs change over time? How will the application be managed and monitored? How do you know if the application is working? How do you deal with problems? How will the application provide durability, reliability, and business continuance? What is the uptime requirement? How will the application meet it? So typically all the hows. And as you can see, I've got even more. All right. So you need to ask the right questions, the right set of questions to clearly understand the functional and non-functional requirements in order to build the best solution possible. So, talking about that, let's go over the case study. So the case study is basically a PDF document that I will share with you in the follow-up email. So you'll receive a copy of that PDF document. Now, before we begin, let me explain. That course was designed to be conducted in person as an ILT, instructor-led training in a classroom. So for me, in a classroom, it would be easy to share a PDF document with you guys, ask you to read it, and then as a group, start exchanging on that document. But now, being virtual, thanks to COVID, that made things a bit interesting, I should say. So it's a bit harder to achieve. So I personally found a way that I think will provide you with a very good experience, student experience, and will make it beneficial even though we're virtual. But in order to do so, I really need you guys. I need you to be interactive. So when I'm going to ask questions, I expect answers from people. And there are no wrong answers. No worries. We'll exchange ideas. Everything is good. Let's just exchange. All right. So when we're going to go over that document together and I'm going to ask questions, do you promise me that you will answer my questions? You'll be interactive. There you go, Paul. I really like that. That's exactly it. Yes. All right. So you'll help me. All right. And the more interactive it will be, the more beneficial it's going to be for you guys and for me as a trainer. You'll benefit from that. You'll see what it really looks like in real life. Awesome. All right, so let's do that. So I've got a copy of my own of that document in which I've highlighted a few things and for which I'm going to use to go over that use case with you guys. So what are we going to do? I'm going to read that with you guys, but I'm going to ask questions. All right. So let's begin. You are the solutions architect for whichever partner, and you are meeting at Case Study Inc. or CSI. You're meeting with Arnie Jones, VP of Operations, Lance Ruiz, Director of IT Finance, and Mr. Gupta, which is Director of Product Engineering. So just looking at those titles, looking at those people, what does that tell you? Does it ring any bell to you? High level. Yes, definitely high level. Yes, it probably is not a small customer. Joe, totally agree. Decision makers. And that's awesome. Oh, not technical. You read my mind, Mohammed. So you can see here, maybe the director of product engineering is a bit more technical. So maybe this guy, you can talk a bit more about bits and bytes. But when you talk about, when you talk to the director of IT finance, they don't care about bits and bytes. They care about dollar sign. So you'll really need to adapt your language when you'll talk to those people. And yes, Matthew, probably not up to speed on current offerings, of course. And that luckily, that's why you are there to help them. Absolutely. You guys are great. That's exactly what I need. You are awesome. So lucky for us, the sales rep and engineer from your team already met with them and build a package of discovery information for us. So let's go over the information that was collected. So Case Study International, or CSI, is a publicly traded company. Publicly traded company. What does that tell us right there? Yes, Iqbal, absolutely. They have to answer to stakeholders. Absolutely. Dennis, regulated. Exactly. Regulated. Low latency. Lucian. Yes, because it's stock market, right? So none of our customers. So there you go. There's probably a lot of regulation right there because they are a publicly traded company. Compliance. So we got to keep that in mind. Absolutely. So they are a publicly traded company offering a variety of services to customers in the United States. With 5,000 employees across several divisions, CSI has been a leader in its space since its inception in 1993. I'm going to stop there because that's important information. especially the last piece of the sentence. CSI has been leader in its space since its inception in 1993. A lot of data. Absolutely. Dennis, pre-cloud, of course. Legacy application, definitely. Definitely. And of course, security is a priority. So absolutely, legacy application. It's old school. Yes, that's it. So they probably really will benefit from that move to the cloud. CSI's patented technology. Oh, patented technology. What does that tell us? Yes, proprietary. Absolutely. So again, most likely even more regulations and even more data security, William. Absolutely. Absolutely. Right? So that's really important. CSI's patented technology has offered customers differentiated value through the years, allowing the business to achieve a customer base of 10 million unique users. All right, so they currently have 10 million users. Originally, CSI customers had to install software applications on the servers in their data centers to use CSI technology. However, with the advent of the internet, CSI abandoned that delivery model and made its application available as an online service. They established their online presence 12 years ago and haven't updated it since. What does that tell us? Well, first, bad updates would make a lot of people unhappy. I'll go with that, Matthew. No security. Yeah, security is probably outdated because it's old software, as Natalie is mentioning. Absolutely. So legacy, outdated applications. That's exactly what we'll need to deal with. Listen, they've been online for 12 years and never updated since, right? Customer experience. Let's talk about that. It's probably easier to start from scratch. Yeah, but we'll see. We'll see. Let's read through all that information that is collected, Paul, and maybe that will actually change your mind. CSI customers pay a subscription fee to access its services. The subscription period has several options, per use, daily, weekly, or monthly. Customers must register with CSI to create an account and purchase a subscription. That being said, CSI collects the following information when users are creating accounts: customer name, customer organization, username, password, address, phone number, email address, payment method, subscribed services, subscription period. What does that tell us? PII, absolutely, Dennis, absolutely. So sensitive data, sensitive security. Yes, private information. We need to properly secure that. So when we design a solution, we need to properly understand that and ensure that the data is protected. Oh yes, Matthew, that would be disastrous if there were leaks. Definitely. All right. You guys are awesome. This data is used to create a unique user account. The data is written to a database. All right. So right there, we know it's in a database when the account is created and is updated infrequently. So the data is not updated or written frequently. And the frequency with which the data is read from the database depends on the type of subscription the user has. Most user data is accessed just a few times a day. So probably we don't need really performant database here. That's not what we're looking for. We're barely accessing that data, or at least not frequently. Oh, of course, encryption. Yeah, so encryption, probably not the same method that we're using 13 years ago. I agree with you. All right. So Mohammed is saying maybe we should consider storage that does not require frequent access. So maybe that's a good candidate to store that data long term. Very good point, Mohammed. We'll see. Let's keep on reading. You guys are really awesome. Keep on interacting like that with me. That's going to be perfect. This data is used to create a yes, we've read that. User data insensitive as a result. Must be encrypted. Well, it is encrypted and must be encrypted. We figured that out, obviously. Now let's talk about the infrastructure itself. So the database, is that used for customer authentication? Let's see, William. That's a very, very fair question. So let's see how they actually authenticate users. We'll see that a bit later. Enjoy. They should shift to fully managed database because they don't like to update. There you go, Joy. I love that thinking. I love that thinking. Absolutely. All right. So infrastructure. CSI services are hosted in a single data center. I'm going to stop there. What does that tell us? No DR, no availability zones and things like that. So therefore, no high availability. So not only isn't there any high availability, there's not even a DR solution in place because there's only one data center. All right. So maybe no load balancing, Iqbal. Let's hold on to that thought. Maybe there's still load balancing, but even if they are in one data center, there could be load balancing among several servers, but they are still in the same data center. So no high availability. So let's keep on going to clarify that. Very good point. So CSI services are hosted in a single data center that is located in the central United States. Each division of CSI manages the infrastructure needed to develop, support, and deliver that division's services. Any updates a division needs to make must be approved by change committee and scheduled during a common change window. Oh, that's important information. Sounds difficult process. Absolutely, Nathalie. This means that we cannot make any sorts of changes at any time, whenever we want. No, we got to work with these guys. Yes, because they are bureaucracy. So you need to fill out paperwork. There are change controls in place that you need to meet. So that's important, especially for larger organizations with such team, such change control team. You got to work with these guys hand in hand. Yes, probably requires long windows. I agree. All right. Awesome. The corporate IT group is responsible for procuring all hardware and software needed by divisions. Service updates sometimes result in downtime of varying lengths, during which some services are unavailable to CSI's customers. That's bad. That's bad. Approval bottlenecks, yes. No QA, no test. Back to needing high availability? Yes, absolutely, Paul. Totally agree with you, Philip. We need high availability. We should not accept downtimes. All right. Now let's talk about the persona application. So users must authenticate to a CSI web portal. Oh, there we go. Now we'll talk about authentication. So the users must authenticate to a CSI web portal using a login and password before accessing the services included with their subscription. After authenticating, the portal issues a service access token that is stored on the device from which the user accessed the portal. All right, so we understand that. Let's keep on going. While each division maintains its own service delivery infrastructure, CSI relies on a homegrown web application called Persona, built and managed by CSI Corporate IT to control user access. All divisions use Persona as the gatekeeper for their services. If Persona is unavailable, customers cannot access any CSI services. Oh, so you guys are starting considering maybe alternatives to the authentication process. Very good idea. Very good idea. Single point of failure? Yes. So again, high availability. Aren't we coming back to that all the time? So maybe Lucian, hopefully I pronounce your name properly. Lucian is saying maybe introducing MFA. Very good idea. Very good idea. Love that. I love that. So see, already as solution architects, you start thinking about the solution that is required to address the customer needs. That's awesome. Let's keep on going with that. So the Persona architecture, the Persona web portal is a three-tier web application. What is a three-tier web application typically? Sorry about that. Yes. So we've got front end, middleware, and back end. So typically web app database. Absolutely. You got it. All right. So that's what they're using. And it is hosted on dedicated servers in the CSI Central Data Center. Here are the details of the architecture. The servers in the data center run VMware ESXi virtualization software. Oh, that's important information. Why is that? Why is that important? VMC hybrid. Oh, makes it easier to port. Maybe yes, maybe no, but that's a good point, Dennis. Absolutely. But yes, absolutely. Uluwatoyin. Sorry about that if I mispronounce your name. You are correct. They can relate to EC2. They have virtualization knowledge. So we should keep that in mind. Absolutely. Absolutely. The Persona web server and middleware components use IBM WebSphere running on Red Hat Enterprise Linux virtual machines. All right, here what it tells us is that it's a bit costly to run that, probably. All right. Yes, VMware on cloud could be an option, Ravi. Absolutely. The application itself is written in Oracle Java and uses web technologies such as HTML, CSS, and CGI. The Persona database relies on Oracle RAC servers running on physical hosts. What does Oracle RAC means? Massimo, you already have a solution in mind, and it's pretty complete. Absolutely. Well, keep that in mind. We're gonna go further on with that, and maybe you'll apply some of that. Absolutely. So yes, it means cluster, real application cluster. So basically, it's a cluster of Oracle servers. So at least there's some redundancy there, high availability there for their database. So most likely we should consider something highly available as well on AWS Cloud. All right. And also that Oracle RAC is, again, fairly costly. So maybe if we can find a better alternative, that's something to consider. The entire application is protected by a pair of firewalls behind a pair of F5 load balancers. Can we achieve something similar on AWS Cloud? Yes, absolutely. For the firewalls, what can we use? The web application firewall, of course, but I've explained as well, there are two virtual firewalls we can use. Yes, AWS Shield is for the DDoS attacks, absolutely. So if you remember, the NACLs and the security groups, absolutely. And yes, of course, all those gateways or components of the VPC is also a layer of security in a sense that we need to define route table entries. Absolutely. So all three together, I think it's perfect for the firewall part. And then the load balancers. No, I know, Mohammed. Absolutely. I agree with you. So load balancing, can we use something to address that? Do we have something on AWS Cloud? Yes, Paul, absolutely. ELB, Elastic Load Balancer. You remember? That's going to load balance the workload across your fleet of EC2 instances? Absolutely. And it can be used for EC2 instances. It could be used for RDS databases. It could be used in many ways. So it's going to load balance the workload. Absolutely. You guys are awesome. So we have a graphical representation of that architecture here. We've got the users that are coming in through those load balancers, the firewalls, and then they access the web servers. And the web servers access the application servers whenever needed. And then the application servers will access the data in the data server or the database servers if you wish. So that's a pretty good representation of what they're doing at the moment. CSI stores customer activity for 7 years to meet compliance requirements. CSI would like to make use of this customer's activity data for BI purposes, but that has not done so yet. All right. So right there, that's an important information. Yes, web servers, not in DMZ. And we'll talk about that, Lucian. It's really a good point there. Some people are talking about Glacier, maybe to store data for long-term retention. Very, very, very good idea. And then out of S3, we could definitely start doing some maybe data lakes or data warehouses where we can analyze that data and run any sorts of BI against it. So I love the idea. Availability issues. On 2 occasions in the past year, the Persona service has experienced service outages. Oh, that's bad. One of the outages was attributed to a hardware failure. Can we address that on AWS Cloud? Yes, with high availability, which means more than one AZ. So even if there would be a hardware issue on one of the physical server that runs one of your VMs in one of the data center, well, it's not a problem. Because remember, there's even a health check mechanism in the auto scaling group that will notice that, will kill that virtual machine and start a new one. Or it can fail over to another AZ. Absolutely. So yes, we can address that, definitely. The other was caused by human errors. Can we address that? How? CloudTrail? Well, we fire the employee. I love that. But if we were to fire employees when they make a mistake, we would probably end up with no employees at all. But yes, you get the idea. I think it's infrastructure as a code. Yes, use code to avoid errors. Of course, you could use CloudTrail to figure out who made that error. But CloudTrail will not prevent you from doing that mistake. However, automation and infrastructure as a code will help you. No, Paul, that's not true. I do not agree with that. Not because you're using AWS, you don't need employees anymore. Actually, you can have your employees focus on what's important, innovation. See there? All right. And in both cases, CSI was forced to issue a public apology and compensate customers for the inconvenience. That's bad. That's bad. Yes, lack of trust. It actually destroys your reputation, or at least impacts it a lot. A lot. My bank lost or leaked by mistake lots of personal information. Do you think I have the same trust with my bank now? Absolutely not. And that's damage that cannot be repaired, if you wish. Once you lose the customer trust, you'll typically lose it for good. Yes, exactly, Paul. So you remember that, right? So I guess I was not too far from the truth. All right, so now there's also cost issues. The cost of operating Persona has increased substantially. The hardware that hosts the database and virtualization platform is reaching end of life, and software licensing costs are also increasing. CSI is reaching the end of its contract with its current colocation provider and is looking for ways to decrease its real estate costs. So that's an important paragraph. Yes, it is time to move to the cloud. There is absolutely no way they can go with status quo. They gotta move as soon as possible. It actually is the perfect occasion to do that move. That's it. The perfect incentive. All right. The hardware and software procurement processes at CSI are lengthy, complicated, and cumbersome. Once procured, deployment often takes weeks or months. Change windows also lead to service disruptions for customers. So again, for that, first, the hardware, don't think it's going to be a problem anymore because we'll probably add, thanks, Mohammed. So yes, we'll probably add high availability here. So that will avoid the service disruptions. And there's no longer any hardware procurement. So that's going to be something easy to address. So Persona was state of the art when it was developed, designed to support customers connecting from personal computers. The Persona portal is not friendly to mobile computing devices. Additionally, Persona is not capable of supporting automated service access for maybe impaired users. All right. So that's something they want to address. Now let's talk about competitive issues. And this is where you'll fully grasp what I was saying when I said you must learn about your customers' competitors as well. All right? You'll see. CSI's market dominance is under threat from a competitor. International Case Study, or ICS. ICS entered the market 5 years ago, offering services similar to CSI's. I'll stop there. What does that tell us? They entered the market 5 years ago. They offer new service. They are newer, absolutely. So they are probably cloud enabled already. Absolutely. Newer tech, newer apps, definitely. Let's keep on going. Offering services similar to CSI, but at a lower price. Probably another proof that they are already on cloud. Yes, definitely, Matthew. Absolutely. Making matters worse, ICS has been able to expand and enhance its portfolio of services because they have a much more quicker pace of innovation. So again, another proof they are in the cloud. ICS is offering customers more usage options and personalization that adjust service behavior to reflect the needs of each customer. ICS has also been able to establish a presence in the Americas, Europe, and Asia. They went global. Again, another proof they are on cloud, maybe even on AWS cloud. As a result, ICS has been taking market share from CSI in the United States. CSI must modernize or face obsolescence. So see how important it is to know about your competitors. That's a pretty good proof right there. ICS is on fire. Yes, Joy, absolutely. So now let's talk about Project Shapeshift. CSI management has committed to an aggressive modernization program that they are calling Project Shapeshift. This program is scheduled to launch in 6 months. I'm going to stop there. There's an important information here. Paul is saying that's a lot of time to set up AWS. I don't know if you say that with irony, because 6 months, I think, is really short, in fact. 6 months, and we're still just at the information collection phase. We haven't even started designing a solution, let alone start migrating it. So it really is short. It is aggressive. All right? So think about that. Keep that in mind. Because yes, Lucian, absolutely. They need time to test the application from all angles. So that takes time. All right? And they want to touch on every aspect of CSI's operations. So they want to expand CSI's service portfolio. They want to reinvent product development processes to support rapid product innovation. They want to enhance the experience of every user. They want to improve operational efficiency and service availability while lowering costs. And they want to provide CSI with a global market platform. So that is a lot in just 6 months. Challenges. Canary development for starters. Love that. That's a very good idea. Let's see. Let's keep on going with that. You guys are great. Again. With CSI's entry into the global market, CSI's customer base is expected to grow. Internal business analysts estimate that the user base is likely to exceed 50 million users within 2 years. That's important. Important information. It means our solution must scale, right? And yes, total advantage to cloud scalability to achieve that. Persona, in its current form, cannot support this increase. Scalability testing of the Persona database platform has confirmed that it can support no more than 30 million users. So another proof that status quo is unacceptable. We cannot do that. We got to move. CSI CIO has been considering a move to AWS. However, he and his team aren't sure they're ready. While the IT team would like to adopt an AWS first strategy, they are concerned that the current operations team does not have the cloud skills necessary to support that approach. That's important. Those 50 million users heard of ICS? Let's hope not. Let's hope not. I love that. A few CSI's engineers have been using AWS resources to develop and test applications. However, CSI has not placed any production workloads in the cloud. Some current stakeholders are heavily invested in maintaining the current technology. Of course, they preach for their own church. They may be managing a team that was in charge of the data center. So now they're afraid that if they move to the cloud, all those people will lose their job. Of course, that's something to consider for a stakeholder. Support team could become obsolete. Yeah, so those are things to consider. Project Shapeshift is scheduled for release in just 6 months, and Persona application must be ready for the launch. So we're done with the information collection package. So as you can see, how did you like the use case? It sounded like a real use case, right? Things that we've seen out there, legacy applications, outdated technologies that now needs to be moved to the cloud. So it really speaks to me. That's pretty cool. All right, now let's look at what we can do to actually build that solution. All right, so let's do that. All right, so here are the functional requirements that we found for that application. So first, the purpose of the application is to enable users to register and log into the organization, permitting access to other applications. So the inputs and outputs. Well, humans create new registrations using web and mobile devices, which generate some data. Some is machine generated, such as the timestamps and the dates, but some are generated by humans, such as, for example, username and things like that. Successful registration generates a welcome email or text. Machines pass a request for a login. So humans will be asked to provide a username and password, and successful login generates an authentication token for use by other applications. Yes. And then, what else did we discover? The non-functional requirements. We need scalability. Scalability for 100 million users. 100 million users. How many users did the internal business analyst projected having? 50 millions. Why asking for 100 million here? Yes, for future growth. for scaling. How many years did they expect reaching that 50 million users in 2 years? That's really short. Do you want to suggest a solution that will last only for 2 years? No, of course. So you want something that will last for a lot longer than that. So let's target a scalability of 100 million users. But if our solution can actually scale even more than that, that's just better. But let's target that. Privacy and compliance. We need to protect sensitive personal data. We've talked about that. They want to be always up and running. So as far as uptime goes, they don't want any planned or unplanned outages. So the goal is 100, but they would accept 99.99%. So of course, we need to provide high availability. Definitely, we've figured that out. Usability. They want to support major web and mobile browser and support for vision and mobility challenged users. And maybe add additional languages since they want to go global. Well, if I look at that, that might not be let's say an AWS problem, but we need to add that into that new solution and consider that. All right. So now let's look at each and every of the services and what we could propose to address that. So first, let's talk about data services. Where are we going to store? Sorry about that. Where are we going to store the data? So data elements are simple. We've got username, password, and some additional information, which represent 1 kilobyte or less per registered user. The total scale is difficult to predict, but could be large. So we want to support 100 million users, and that could increase. So we need fast performance, but not sub-millisecond. We want to be able to scale up and down to meet changing needs. And the current staff has strong relational database skills. So what service would you suggest? Would you recommend to store that user information? So Paul is talking about auto scaling, but RDS. So RDS, absolutely. I would go with that. RDS, we could go with RDS for Oracle. So that would be a simple migration process. We could even go with Aurora, for example. So that's another platform we could use. So you guys are targeting RDS. Totally agree with that. And that allows you to scale because you can actually scale the storage used by those databases. So you'll be able to scale up. But scale up and down would be a bit harder with RDS for Oracle. But Aurora scales in and out automatically for you, if you remember. So Aurora could be a good use case for that. And they have strong relational database skills. All right, so you guys went with that. Now let's go. Oh, can you port Oracle licenses? Well, if you go with RDS for Oracle, you can go go either way. You can either bring in your licenses, and of course your subscription fees will be adjusted accordingly. Or you could go with built-in licenses, which are part of your subscription. So either way is good. It's up to you to decide what you can do. But that's a very good point. But if you remember, they're actually reaching end of life. So that would not be a good use case for bringing your own licenses. All right. So what are these guys recommending here? Well, first, when we talk about the data, it's a transactional problem, not business intelligence and analytics. So we don't need any of those advanced services such as Amazon EMR and Redshift or Athena, which is really used for that BI stuff and analysis stuff. So that's not what we need. It's not a graph problem. So we don't need to provide a database with highly connected data sets. So that's not what we need. So Neptune is out of the way. So we need a database service. Do we need Elastic Cache for extremely low latency? Not really, because remember, we're just accessing that data on a infrequent basis. So therefore, we do not need something like Elastic Cache. So we need for scaling consistent, fast performance database. Can we meet that with DynamoDB? Absolutely. We could do that with DynamoDB. Would you go with DynamoDB? Yes. Lucian, absolutely. It's non-relational database. And these guys do not have any knowledge about non-relational databases. So that would not be a good fit. Not only that, but also that would mean redesigning, rewriting the application. No, we don't want that. We only have 6 months. All right, so let's take out DynamoDB. So we can either go with Aurora, or we could go with Oracle for, not Oracle, but RDS for Oracle. So let's keep those two in mind for the moment. All right, next, let's talk about compute and storage. So the current staff has strong Java skill. They want to keep their application in Java. All right, it's not really an AWS problem, but let's still consider that. The total scale for the computing resources and storage is difficult to predict, but could be large. We want the ability to scale up, scale down to meet the changing needs, or scale out, scale in, depending on what you plan on doing. Serverless could work. We want to minimize change from the legacy registration system. So for computing resources here, what would you recommend? So EKS, containers, so containers, or even Lambda and Fargate for containers, or ACF, those are good choices. Would you go with that? I love that. That would be performant. That could scale as much as you need. Do you guys agree to go with that? Go with containers? Or serverless? Go with Lambda? Containers, serverless. Oh, so see, opinions are kind of split in between. All right. Let me be the devil's advocate. If we go with containers or containerized application, or if we go with serverless computing, it involves a complete rewrite of the application. Is it something you would like to consider at this point and go through? Nope. Why is that? Because of our aggressive 6 months deadline. So we don't have time to redesign the whole thing. However, this doesn't mean that it was not a good idea. Remember what I said earlier on today. Moving to the cloud is not a destination. It's actually just the beginning of your journey. Nothing prevents you, after that 6 months, after everything runs fine on AWS Cloud, to then get in a second step where you could redesign the application and leverage serverless computing or containers. Totally agree. But at first, as William mentions, we should consider a lift and shift migration, and then later on get to that new technology, just because of that deadline. Awesome. And now for the storage needs. For the storage needs, well, of course, there's the database, of course, but besides the database, we will need local storage for application servers, so to install the application if you wish. And then we will need backup. So local storage for application servers, what would you go with to install your applications? Of course, EBS, your block storage, right? So you can present a volume to that EC2 instance and then install your application on that volume. But then you need backups. What would you use for backups? Paul says Glacier. Do you guys agree with Glacier? Oluwatoyin is saying S3. Would you rather go with S3 or with S3 Glacier? William is saying no, does not agree. And the reason is quite simple. If we're talking about backups, probably this is backup of important data. critical to our servers. So if you go with S3 Glacier, this means that you do not have instant access. So probably S3 Standard is a better fit for those backups. However, as you are mentioning as well, maybe going with S3 Intelligent Tiering. That will be even better. We'll look at that data and we'll move it around for you. So that gives us some options. But keep in mind that if we go with Glacier only, there is the problem that you do not have instant access to the data. You must first restore it in S3 Standard, and then and only then can you start restoring it on your servers. Keep that in mind. All right? So let's look at what these guys are recommending here. So for the Java skill and all that, we cannot do much here. It's not an AWS problem, but we could manage Java using maybe open source things like Apache Tomcat. So that's going to be less costly. And now as far as computing resources goes, they wanted to be able to scale. So as you guys mentioned, we could go with containers. That can scale really easily. We could even go with Lambda functions. That's great, but it adds too much complexity. Keep in mind that this would involve a rewrite of the application, and we want to avoid that because of the 6 months deadline. So I think the best choice is to go with EC2 instances with auto-scaling groups. And that's what you guys proposed. And now for the storage, you guys nailed it. EBS storage, and then S3 for backups. But if you use Oracle RDS, you don't need backups. No, for the database, you are absolutely correct, Lucien. Absolutely, because it's handled by AWS. However, think about your web servers and maybe your app servers. Depending on if you've got some important stuff in there that you need to back up, that would be different. All right, just keep that in mind. All right, you guys are awesome. Now let's look at the networking and security. So they need load balancing amongst the web servers, the app servers, and the data servers. Only the web servers should be accessible from the internet. All data should be encrypted in motion and at rest, and they must be able to pass corporate security audits. So let's start with the load balancing. Can we achieve that ELB? You mentioned that, Matthew. Absolutely. So we could go with ELB. Now, something to understand. For the web servers and the app servers, Aurora. So if we use Aurora, we don't need an ELB for the database. If we use Oracle for RDS for Oracle, we will need an ELB. So let's keep that in mind. Only the web server should be accessible from the internet. So Lucien, you're talking about the virtual private gateway? Well, not necessarily, because we're talking here the web servers being accessible from the internet. So in that case, maybe not a virtual private gateway, but more an internet gateway. Internet gateway will allow that. And yes, web servers will be in a public subnet. Maybe, maybe not. We'll see. But you got a good point. There's something that must be in the public subnet so that we can reach it, right? Or NAT gateway as well. All right, so we can ensure through all our network-based security controls that only the web servers are accessible from the internet, nothing else. All data should be encrypted in motion and at rest. Can we do that? Can we do that? Yes. And we can manage the keys using KMS. Absolutely. Absolutely. Must be able to pass corporate security audits. What could you use to help for that? Oh, CloudWatch, absolutely. But something else? CloudTrail. Yes, CloudTrail. CloudTrail and CloudWatch will help you with that, but especially CloudTrail. Especially CloudTrail. Really important to pass corporate security audits. Now let's see what these guys recommended for that. Well, first, ELB for the web and application servers. And Aurora, as I mentioned, is already a single entry point. So with automated balancing, no need for that. If we go with RDS for Oracle, that will be different. We will need a load balancer. So of course, if we talk about security groups, IAM permissions, if we talk about NACLs, if we talk about internet gateways, NAT gateways, virtual private gateways, we can configure all of that in a way where only the web servers are accessible from the internet. We can do that easily. Of course, we can use VPC components and encryption options on our services to encrypt the data in transit and at rest. You mentioned that. You nailed it. And then we can consider CloudTrail, CloudWatch for security audits, as well as some additional tools that are not covered in this course, but just to give you an idea, Amazon Inspector, Guard Duty, and AWS Shield, pretty cool tools to help you pass corporate security audits. And know that those services are covered in the Cloud Practitioner Essentials course. All right? So you guys are great. So 2 more slides before we start designing the solution. For monitoring and management, they must be able to alert and mitigate when the application fails. For a technical failure, so when a service does not operate or reach a limit, for example, a server running out of space, how would you address that? CloudWatch? Lambda function triggered by CloudWatch alarm? I love that even more. Awesome. That's exactly it. And then a business failure, when a user action causes a failure. For example, not using a valid email address in the email field. Well, that is not really an AWS problem. But these people should add validation controls in their application, definitely. Right? So we should do that. But there's not really a way from AWS to address that. They must be able to monitor activity, and they want a dashboard to show the current activity and a method to understand errors and find root causes. So CloudTrail, definitely a good candidate for that. And here they'll even suggest something CloudWatch as well. Definitely CloudWatch. So those two, CloudTrail, CloudWatch, always important monitoring services. But I'm going to show you that we can take it one step further. So here's what they're recommending here. Technical failure, CloudWatch with an alarm, such as a Lambda function. That's exactly what you guys mentioned, exactly what you proposed. That's awesome. So business, of course, that should be in the code. They will need to have validation checks. But then for the monitoring and the dashboard for the current activity and methods to understand root causes, understand errors and root causes, well, you could have the application emit logs to an S3 bucket. And these logs, combined with CloudWatch and CloudTrail data, you could use Elasticsearch to create a dashboard and searchable forensics. So see here, we can even go for a customized monitoring solution for them. Oh yeah, if you use SQS for the email address, yeah, but SQS, yes, I agree that SQS would notice if an email address fails, but it doesn't mean that you really want to send a message. But you could leverage SQS. Yeah, you could. You know what? I like the idea. You could use SQS to test that. I agree. Awesome. Awesome. You brought up a brand new idea to my mind. I love it. All right. And last but not least, let's talk about migration and cutover. When we going to migrate the application? Well, first, for the database, they want to be able to move from Oracle to either Aurora or RDS for Oracle, and they need zero downtime for migration. What should they use? Database Migration Services, DMS, Matthew. Absolutely, absolutely. And that's pretty cool because Database Migration Services, the way it works, it creates a replication pair between the source and the destination. So basically, you are replicating your source database to your destination database. So the first replication will take longer. But then afterward, you go with incremental synchronizations until D-Day, when you want to pull the switch, you flip everybody over to the new database. All right. So near zero downtime for that. That's awesome. So DMS is great for that. For the application, we need to cut over from legacy web and application servers to the new system. Again, we need a near zero downtime, and we must have the ability to fail back if problems in the new system appear. So what would you suggest for that? Somebody mentioned something already that I did like. Yes, Lucian, Canary deployment? We could do that, right? We could have just a small portion of users use the new application and all the others use the old applications. Can we do that? Do you agree with that? How about you guys? Do you agree with Lucian's idea to go with a Canary deployment? So just a small subset of people first? And then even increment the percentage of people over the new application? I like the idea. But yet again, let me be the devil's advocate. What if maybe let them know they're part of the beta? It's not even a problem with that, Matthew. Let me explain. If you migrate just a subset of data, of users, that means that you'll have, let's say, 10% of users writing data into the new database. And you'll have 90% of your users writing data into the old database. Do you see a problem there? That will lead to data inconsistency. Because you are correct, Lucian, that the replication is one way. It could actually be the other way. So if there's a problem and we want to fail back, we could actually replicate data backward. But we cannot replicate data bidirectionally at the same time. So that's a problem. All right, so discard the Canary deployment. So we should instead go what we refer to as a blue-green deployment. Blue-green meaning that you've got an old system, you've got a new system, and on D-Day, you flip over everybody to the new system. And if there's a problem at any given point, you're going to have users that will write new data here. So if you want to fail back to your old database, quite simple. Using the DMS service again, you simply replicate those small changes here back to the old database and then flip your users back to the old database. So we call that a blue-green deployment. All right, so you need a failback solution for that, and we can do that using, yes, just like a DR, basically. So again, it's going to use the DMS service, but you can see why we cannot use Canary deployments because of that. All right. Now, let's propose an architecture to our customer because we found We found great ways because that's exactly what we're saying here. We can use DMS to migrate the whole thing, but canary deployment is going to lead to data inconsistency. So therefore, we got to go with blue-green. And if something happens, we can fail back again using DMS. So we've explained all that. We've covered that. Now, here's the proposed solution. And I'm going to propose a solution. I'm going to design a solution with you. And I'll actually apply all 5 well-architected pillars to that solution. And you'll see how simple it is. All right. So let's begin. I could start with a first draft that could look like something like this. So as you can see here, we still got our 3-tier application. So the web tier, the app tier, and the data tier. I could, of course, expose my web servers directly to the internet. I could do that. But one of the best practice on AWS Cloud is to actually use a public subnet to host your gateways, your internet gateway, your NAT gateway, and all of those. So having your gateways here, you don't even expose your servers there. You just expose the gateway, which makes it even more secure because this here is now a private subnet instead of being a public subnet. Only this one here with your gateways actually is a public subnet. And if you need to access those machines, you can even use a remote desktop gateway, which is basically a jump box hosted on your public subnet that you can connect to access those additional systems in the private subnets. That's pretty cool. So you don't even expose those private subnets in any ways. And I could go with virtual machines, so EC2 instances for each tier. And here I could go either with RDS for Oracle or RDS Aurora. So either way, I'm good. But as you can see, that's a very crude first draft. I'm only using one AZ. So obviously, I did not apply any of the pillars yet. I just came up with a very crude first draft. Now, let's apply those pillars. Let's begin with reliability. So to add reliability, well, of course, we need high availability. So for that, we could instead go with 2 availability zones. And then have 2 sets of virtual machines and have a load balancer in front of it to load balance the connections amongst all my virtual machines. So I can do that for my web tier. I can do that for my app tier as well. And if I go with RDS for Oracle, I would need one here as well. Or if I go with Aurora, I do not need to do so. So already I added some reliability. On top of that, maybe I could introduce the web application firewall intrusion detection systems. So AWS Shield, for example, we could add all those services here. So Guard Duty as well, which is another service. We could implement all that, and that will provide us with reliability. For the database part, we can have a main database and we can have a replica. So that way, if anything happens, we can easily fail over to the other one. So I've addressed the reliability pillar right there. Cool, isn't it? Not that complicated. So let's get to performance efficiency. Well, first, performance efficiency involves also deploying your environment. So you need to ensure that you deploy it in a performant way, to deploy it as quickly as possible, and ensure to have the right resources. So in that case, AWS Cloud Formation. Use that. And then we want to add performance. So in that case, performance, if you remember, is also the ability to adapt with the demand. So we could start configuring auto-scaling groups. So I could have an auto-scaling group for my web tier. I could have an auto-scaling group for my app tier. So therefore, if I'm lacking resources, the system will automatically spin up additional instances and it will register those with DELB. I'm good. I'm great for that piece and that piece. Now for the database. Well, if I want to be able to scale automatically, I could go with RDS for Oracle, but RDS for Oracle does not scale automatically by default. So you set a size, for example, 100 gigs. Once you reach that 100 gigs, you need to expand. So you can add another 100 gig or 200 gigs, whatever. But you must do it. It's manual. Of course, you could set a CloudWatch alarm, and once you reach saturation, you could launch a Lambda function that would automatically scale it. So, Lucien, see, I just read your mind. So yes, you could do that. But by default, it's not there. As opposed to Aurora, if you remember, Aurora has scaling capabilities that are built in. So it will automatically scale out as needed and scale in as needed as well. So, all right, we're going to go with Aurora. That will address our performance efficiency pillar. All right. And then cost optimization. All right, that's another important pillar. So for cost optimization, then I can start thinking about different purchasing options for my resources. So for example, in that auto scaling group, there's going to be instances that will constantly run 24/7. That's my minimum number of instances. Well, for those, which I know will constantly run, I could use reserved instances. And then when demand increases and the auto scaling group must spin up additional instances, those could be on-demand instances. And yes, you can do that. In an auto scaling group, you could have a set of virtual machines that are using a specific purchasing option, and then another set, let's say when you scale out, that will be using another purchasing option. So as you can see here, I'm going to save money for the ones that constantly run, and I'll pay a regular price for the ones that I spin up whenever needed when demand increases. All right. So right there, I am helping with the costs. And then for the database, and I can do that for the app tier as well. And then for the database, well, if I go with Aurora, what I mentioned is that Aurora not only is more performant than the other RDS vendors, but also it's cheaper. It's 1/10 of the price, which makes it really affordable. So right there, if I go with Aurora instead of Oracle, RDS for Oracle, I will save costs. So huge advantage right there. All right. Then let's talk security. And here, as you can see, there's probably a lot more you can do with that pillar than the others. So first, I could put in place for each subnet, I could put in place NACLs. I could do that. I could also create security groups for my virtual machines, right? So that way, I only allow specific traffic in or out from my security group. And it's easy to implement, by the way. So you could say, my web tier security group can talk to my app security group. So that's how you create your rules, really easy. So that way you ensure that only the servers from this group here can access this group there. So really easy to set up. You can even configure security groups for your database services. So I would create a security group here as well and would ensure that only the app security group has access to that data security group. Nobody else. So right there, you can make it really secure. But then you can add on top of that all those other security layers and features that are available out there, such as, we've mentioned that, right? AWS Shield, or encryption and manage those keys with KMS or the web application firewall. And we should restrict the access to all the resources and services through identity and access management, or IAM. And then to ensure that nobody changes those configurations, I can monitor the whole thing using AWS config and compare that with my rules. You mean, would there be any reason to choose RDS for Oracle over Aurora? Not really, because Aurora is more performant and it's cheaper. So there's not really a use case to stick to RDS for Oracle if I apply the pillars. But yes, you are correct, Lucian. Maybe these guys would prefer that because they are knowledgeable about Oracle. Then that's a complete different game. You would need to stick to that if that's a request from the customer. But if you really want to stick to the pillars and explain to the customer, listen, if you want to optimize costs, you could go with Aurora instead. Absolutely. Those are very good concerns. And then for security, of course, we should log and trace every change in the environment or every interaction with the environment. So CloudTrail is there for that. So as you can see here, I've applied several security layers to my solution. So then I can improve my operations with the operational excellence pillar. And this here, we can start thinking about CloudFormation, of course, we know that, but also start thinking about DevOps a bit more, and then have everything defined as scripts and codes as much as possible, and manage all that using CodeStar. So where you can start configuring repositories with approved pieces of code that you can reuse, code pipelines. Exactly. So you can see here that I can introduce that as well to improve my operational excellence. So when you look at that, we just built a solution that we can present to CSI and say, listen, we've built that solution and we've applied all the pillars. Of course, it's an easy scenario here. There's not too many services involved. Although when you look at that, it starts to be a bit complex, right? We've introduced a lot of services and components in our design, but still it was fairly simple to build. Oh yes, I will tell them that there were 55 people involved, so they will certainly approve that design. I love that, Paul. I'll keep that in mind. I'll remember that for upcoming classes. So now you'll be able to present that. You can also present with that the well-architected framework report, showing them, listen, I've answered to all those questions, so I didn't leave any stone unturned. They're all covered here. So that's what you can present your customers, and they'll feel comfortable making that move because you've covered everything. And once you're done, once they move to the cloud, you're done. You can sleep well. No, actually, it's just the beginning of your journey. I mentioned that already because now you've got access to so many things. Of course, we had an aggressive deadline of 6 months. So nothing prevents us from going with a first phase, which is the sole lift and shift migration of that application to AWS Cloud. But then you can start innovating, iterating by using additional services. So for example, you could start thinking maybe redesigning your application into a more microservices way, and maybe leveraging serverless computing such as containers or Lambda. Yes, that could be a second step, Paul. Absolutely. You could think about maybe starting doing some BI, some business intelligence, some analysis of the data, because remember, we're keeping some historical data. So we could start doing BI against it. You could start implementing a real DevOps mentality, methodology with CI/CD, and again, using CodeStar maybe. You could start looking at the database. Maybe after a while, it's going to be time to make a shift to DynamoDB NoSQL database because it's more performant, more scalable. Of course, you can always improve manageability and scale and security, but then you can start looking into performance as well. And always try to optimize costs. So as you can see, not because you have moved to the cloud that you're done. It's actually the beginning. And that being said, time to review. I won't go over all that. We've gone through that so many times already. But what I want to show you here are a few slides first. When you sign up for an AWS account, you've got access to free tiers. Leverage that. Those are good for you to learn, to experiment, to use the well-architected framework tool, for sure. It's free of charge anyways. All right? So leverage that. And also remember that there are SDKs. So as a partner, if you're actually building an application, a solution that must interact with AWS resources and services, well, SDKs are there for you. They use several programming languages that we do support and will allow you to actually build your application that will directly interact with AWS. Also, talking about the learning path, what are the next steps? Well, you are here. We just completed that course. Next step should be the Cloud Practitioner Essentials course that will then prepare you for the Cloud Practitioner certification. So that course, the Cloud Practitioner Essentials course, I strongly recommend it to you guys. We go in greater depth into the services. We do demos. We do whiteboard sessions. We even cover the Cloud Practitioner exam basics. So pretty interesting course. So that would be your next step. Talking about the certification, as I mentioned, that's the first certification, the base certification, foundational certification, Cloud Practitioner. But then you can take any of the verticals. So if you're more into DevOps, you could go with either one of those verticals. Or if you're a solutions architect, you can go with that vertical. So this will then allow you to become a certified associate. So solutions architect associate or developers associate. And then you can become a certified professional. So of course, those involves additional trainings, additional courses to attend, and then another certification exam. Once you are certified as a professional, then you can start looking into specializations such as machine learning, for example. All right. You could actually go directly from here to there, but I strongly recommend not doing so because here we take for granted that you've been through a vertical and you've got some basic knowledge that is covered in those verticals. So this is why I strongly recommend you should do this first, and then you can get into a specialization. And of course, I've shared with you already that information about the well-architected framework. Remember that there's free online training, half a day, really useful. Some additional security training as well. And when we talk security, what you should always do when you want to learn about security, aws.amazon.com/security. That's going to bring you to our main security page where you can have access to a bunch of information about security. There's a bunch of white papers. There's even a penetration testing, a bunch of resources available for you. No matter if you're looking for network security or user security, any type of security, this is where you should start go and begin with. All right, and then some additional resources. So if you've attended for more than 60%, you'll get a copy of that slide deck, which will include all those links as well, and some recommended reading. And that's it. We've done it, guys. You guys were really, really, really great. I really appreciated that day. You were interactive. Hope you liked that use case that we went through and the solution that we built afterward. Hope it was beneficial to you guys. I really enjoyed it and cannot thank you enough for your participation into that activity. Thank you so much. Awesome, awesome. All right, so next steps. Probably tomorrow, not tonight. So don't start sending me emails tonight. Probably tomorrow, and tomorrow Eastern time, not Germany time, Eastern time, because you probably are tomorrow already in Germany, right? So, yes, tomorrow, most likely you'll receive two emails. One, which will be an automated email with your certificate of attendance and a course evaluation link. Please, pretty please, I ask you to take 5 minutes once you receive that email to go and fill out the course evaluation. This is how we are being evaluated. This is how we improve things. This is how we keep doing stuff you like and we stop doing things you do not like. All right. So just to give you the best experience possible. So please take time to do so. And then you'll receive another email directly from myself where you'll receive a bunch of links, a copy of that slide deck, as well as a copy of that use case we went through. So you'll be able to refer back to it. All right. So that's what you should expect. I thank you so much. I'm going to stick around for a couple minutes in case you've got questions. If you do not, simply leave the session, and I wish to see you in an upcoming training. Thank you very much. And again, Amanda, you'll get a copy of the slide deck, but not any recordings. There are no recordings. All right? Thank you. Thank you, everyone. All have a great day. All right, since there are no questions, I'll simply close the session and hope to see you in a future training. Have an excellent day, everyone.